Hello everybody, this is Dr. Padmashri, lecturer in geology, Government College Autonomous Anantapur. Hello viewers, today I am here before you to speak a few things about structural geology. All of us know structural geology is a very important component. So what is structural geology? Structural geology is nothing but the study of structures. So minute structures or major structures, any structure can be studied under this component structural geology. So how are structures formed in rocks? Let me tell you one example. We human beings, when we are subjected to some stress, what happens? If you are subjected to any stress in your examination, stress in your class, stress in your family, what happens to you? You exhibit some strain. Some strain is seen, stress is not seen, but strain is visible in the form whether you may be angry or you may be disturbed or whatever it is. So, stress gives strain to a human being. In the same way, stress gives strain in the rocks, which is seen as structures. Okay? So when you subject any rock to a stress, whether it is a compression or tension, automatically some deformation, the rock formation is changed, and that change is called a structure. So stress is not seen, but strain is seen in the form of so many structures. They may be folded, they may be faulted, they may be cracked, they may be fractured, etc. Okay? Now let me demonstrate by a simple experiment the entire concepts of structural geology. Dear viewers, just imagine this is a horizontal component or a horizontal rock. Okay? So as long as this rock is having strength, and when the stress does not exceed the strength of the rock, nothing will change in it. But if the stress exceeds the strength, and if you just press it on both the sides, it gets folded. Okay, this horizontal component, when a compression is there on both the sides, it becomes folded, and this structure is called a fold. Okay, and now when you increase the stress, you may see so many cracks. So many cracks can be seen in this horizontal rock. These cracks are called joints. So these cracks are called joints. And now further, if you increase the strength, what happens? This horizontal component is torn into two pieces. So if you increase the stress, what happens? It gets torn and you get two papers in two hands. So this is called faulting. Here what happens? One block will go down and the other block may go up. So this is called faulting. So with this example of a horizontal structure, if you increase the compression, it will become a fold. And still if you increase the compression, it will get crack. And still if you increase the compression, it may be broken into two pieces, and that is called a fault. So with this, I want to demonstrate the three important structures: folds, joints and faults. And now, what is another important structure? Unconformity. So what is unconformity? Unconformity is a surface of erosion or non-deposition. See, all of you may be knowing that entire geological time scale, you may be knowing. So the earth, which formed 4,500 million years ago, and the first rock formed 3,500 million years ago, and that is called Archean rock. So after the Archean formation, there was a time gap, and then the next group of rocks, that is the Precambrian rocks, have been formed. So that time gap is called unconformity, which is represented in India by Eparchean unconformity. You can see in the figure Eparchian unconformity is best exhibited by our holy place Tirupati, where in the Tirumala hills you can see the beautiful Eparchian unconformity, where after the formation of Archeans there is a time gap and then the Precambrian rocks have been formed. And now, what are the important structures? Just now I have demonstrated you a horizontal component. When the compression is applied on both the sides, you get a fold. Okay, folds can be seen from the minute rocks to the major folded mountains. All of you know what are the folded mountains in India? Himalayas. Himalayas are the youngest fold mountains in the world. So that huge mountain which is folded is also a fold in a megoscopical form. Okay, and you can see minute folds also when you go through crossing the roads, or when you go by road cuttings or railway cuttings or in your villages. Wherever you go, you can see even minute folds. Okay, any fold which is bent upwards or downwards is a fold, and you can see number of varieties of folds. The only thing is you should have an eye to observe, and you should have a vision to be happy by seeing such beautiful structures. Okay, so this is a fold, and the next one is a joint. What is a joint? So whenever the compression is increased, you may see number of cracks, and those cracks are nothing but joints. So they may be columnar, and they may be prismatic, they may be mural, they may be of so many varieties. And here I want to tell you, my friends, prismatic joint structure is present in the St. Mary's Island of Malpe Beach, Udupi, and also in the Andheri West, Bombay, where you can see beautiful columnar and prismatic joints in basalts, like this. Okay, so joints also in minute sections also you can see, and in major beautiful landscape locations also you can see. And coming to faults, what is a fault? So all along a line, not only there is a crack, but also there is displacement. Fault is nothing but a displacement, where two blocks move, one block goes up and one block goes down. The block which moves up is called the hanging wall, and the block which comes down is called the foot wall. Okay, so faulting is also seen in so many places, in minute sections, in minute road cuttings, minute exposures, up to the major fault. And here I want to tell you, there is a biggest fault in the world, that is San Andreas fault of California, which runs for kilometers. Okay, and now coming to unconformity. I told you unconformity is a surface of erosion or non-deposition. It represents a time gap, and you know it is best represented by a rock called conglomerate, a rudiaceous sedimentary rock. And India is proud to have Eparchian unconformity at our Tirumala hills. Okay, so here in a nutshell, today I wanted to tell you what is structural geology. The study of various structures is called structural geology, and how these structures, how these deformations are formed. They are the result of some stress in the rock, which results in the form of strain, and that strain is seen in the form of either folds or faults or joints or unconformities. And how do you measure the attitude, the behavior of these structures? The attitude or behavior is measured in two components. One is strike and the other one is dip. And here I want to tell you, the attitude is measured by a compass called clinometer compass, and other advanced section is Brunton compass, of which we will be dealing with in the next lectures. For now, the attitude is of two types, strike and dip, and they are measured by an instrument called clinometer compass. And what are the various structures? Folds, faults, joints, unconformities. And now how this structural geology or how these structures are useful? My dear viewers, I want to tell you one thing. Structures may be sometimes helpful and structures may be sometimes harmful also. They give a beauty to the nature. By observing beautiful structures, we can be very, very happy seeing the scenic beauties in the area. And here I want to tell you, structures like folds, unconformities are very good traps, especially for petroleum and oil and natural gas. So if the fold is bent like this, the upper portions, and if the fold is bent like this, V-shaped, the lower portions. So they are very, very good traps for petroleum, oil and natural gas. And coming to the joints, so these joints, when they are filled with mineral matter, they are very, very important. Minerals are present in the joints. For example, gold occurs as a vein. What is a vein? A joint, when it is filled with a mineral matter, is called a vein. So we can see gold, copper, zinc, silver, all these in the form of veins. That is, the mineral matter has filled the cracks or joints or fractures. So they are also very, very economically important. But here we should be very, very careful about the important structure fault. Fault means a mistake. Okay? Even in our life, don't commit faults, because fault is a mistake. So what fault is going to do? Fault is continuously changing process. Continuously one block will be moving front, one block will be moving back. So it is nothing but the displacement of the area. So it is not at all suitable for civil engineering constructions like dams, tunnels, reservoirs, railway lines, road lines. Once you construct a railway path like this, so one line may go to the front and one line may come to the back when a fault occurs. So faults are very, very dangerous for civil engineering constructions, and we should be very, very careful while locating the faults. And unconformity. You know, unconformity is majority of the diamond bearing formations are associated with unconformities, and many petroleum deposits and many uranium deposits are associated with unconformities. So, and here also, while talking about the faults, so there are some features like slick and slides, fault gouges. So when there is even a movement, so when two blocks move past one another also, we may get some mineralization. So we should be very, very careful while constructing some civil engineering constructions like roads, railway lines, tunnels, reservoirs, etc. by taking all these features into consideration. So dear viewers, structural geology is a very, very important topic. You should be very keen enough while observing the structures. It may not be taught in a classroom one day. So from now onwards, every day you go out, you just see what is the structure. If it is bent, think it is a fold. And if there is a crack, think it is a joint. And if any crack is filled with mineral matter, think it is a vein. Okay. And if there is any movement over there, think it is a fault. And if any formations, any two eras are marked by a conglomerate, think it is an unconformity. Okay. So whenever you go to the field, keep that view. So some folded things, some faulted things, some fractured joints, okay, and time gaps. All these constitute the beautiful subject of structural geology. So in our future classes, we'll be dealing with each and every structure in detail. Now I have given you an idea of how a horizontal formation, when it is subjected to compression on both the sides, how it becomes a fold, and if the compression is increased, how the joints or fractures are seen, and if it still increase the compression, how it is broken into two blocks. So all these represent folds, joints and faults respectively. And unconformity also, I told you, it is a gap, time gap in the deposition. Okay, so now what we got to know is, if the rock is subjected to stress, we will see certain form of strain in the form of a structure, and that is called structure, fold or fault or joint or unconformity, and this study is called structural geology. Here in the study of structural geology, we have to know what is an outcrop. What is an outcrop? Anything which is present on the surface of the earth is called outcrop. Anything which you see, a hill, a mountain, a rock exposure, or whatever it is, whatever you see surface of the earth is called a outcrop. So the outcrops are studied for finding out the various structures. Okay, and what you have to study in the outcrop? You have to study two important features in the outcrop which combinedly are called as attitude. So what is your attitude? You may be having positive attitude, you may be having negative attitude. Attitude shows our behavior. Okay, so my attitude is different from yours. So attitude means our behavior. Here also attitude means the behavior of rocks. Okay, so the attitude or behavior of rocks is represented in two components. One is strike and the other one is dip. Okay, strike and dip combinedly are called the attitude of the beds or the attitude of the outcrops. So coming to the attitude, what is a strike? Strike is nothing but the intersection of the bedding plane with the horizontal plane. Okay, as you see in this figure, the bedding plane is intersecting in the horizontal line. That horizontal line is called the strike. Okay, so strike shows the direction of the structure, how it is going, whether it is going in north direction or south direction or east direction or west direction. The direction is shown by strike. The horizontal direction is called strike in a simple form. And what is a dip? The inclination is called the dip. Towards which side the beds are moving, whether they are dipping towards east or whether they are dipping towards west, that inclination is called the dip. So the horizontal line is called the strike and the angle inclination line is called the dip. Okay, so here dip is two types. One is true dip and the other is apparent dip. The dip line, which is exactly perpendicular to the strike line, is called true dip. Okay, true dip means the dip line which is exactly perpendicular to the strike line. And all other dips, there are so many other dip lines which are lesser than the true dip, and they are called apparent dips. They are called apparent dips. So altogether, strike, true dip and apparent dips constitute the word attitude, the behavior of the beds. Okay, so strike is the horizontal line and dip is the line which is perpendicular to strike is true dip, and all other dip directions which are lesser than true dip are called apparent dip directions. Here, viewers, I want to mention one thing. There is only one true dip for one formation, but there will be number of apparent dips. Here I want to tell you, so by knowing two or three apparent dips, we can find out the true dip, and by knowing the true dip and the strike, we can find out the apparent dips. So all these sorts of applications, mathematical applications, will help us to know the dip, the strike, the true dip, the apparent dip, their amounts, their directions, which we can see in our practical classes. Okay, so as for now, the attitude or the behavior of the beds is shown by two components. One is strike, horizontal component. The other one is dip, the inclination. So the inclination in two ways. One is perpendicular to the strike is called true dip, and the other directions which are not perpendicular are called apparent dips. One true dip, many apparent dips, one strike constitute the behavioral pattern of rocks.